Hello Internet and welcome to this quick video on gravitational potential energy, perfect for GCSE Science. Now, we can start by saying that lifting an object up within a gravitational field requires work, and this work put in is transferred to the GPE store. The GPE store is just a shortened version of the gravitational potential energy store. And the equation for gravitational potential energy is our gravitational potential energy, which is measured in joules, equals mass in kilograms times gravitational field strength in newtons per kilogram times height in meters. And this is generally simplified down to EP equals mgh. You will need to remember this. Now, it should be noted that the gravitational field strength on Earth is 9.8 newtons per kilogram. The question will always give you this, so you don't have to remember this. However, most examples will be using Earth. Now, let's take a look at some examples of some questions. If you'd like to pause the video when the question's on screen and give it a go for yourself, feel free. Otherwise, just follow along with me. So, first of all, we are told that a car on Earth has a mass of 2,500 kilograms and is 14 meters above ground. And we are asked to calculate the energy in its gravitational potential energy store. Now, all we need to know here is that in our gravitational potential energy store, we're going to have our mass of 2,500 kilograms times our gravitational field strength. Now we know it's on Earth, and we know Earth has a gravitational field strength of 9.8 newtons per kilogram times 14, as 14 is our height, and working this out we get an answer of 343,000 joules. Please make sure you write joules at the end, as you may lose a mark if you don't. An example of another question here. This one's a little harder as it requires a bit of rearranging. So this time we are told that an object has 12,000 joules of energy in its gravitational potential energy store and is 30 meters from the ground. And again, this object is on Earth. So we are now asked to calculate the mass of this object. So we can start by substituting our values in. So we can say that 12,000 equals m times 9.8 times 30, as we've just substituted values into the equation. And now we start by dividing both sides by 9.8 to get rid of the 9.8 on the right, because we want to get m on its own. Therefore, we're going to have 12,000 divided by 9.8 equaling m times 30. And then again, we're just going to divide both sides by 30. And this will leave us with 12,000 over 9.8 times 30 equaling m. Putting this in a calculator, we get an answer of 40.82 kilograms.